Hello to everyone. As we are going to start the journey of calculus, in which the limit is the backbone of this calculus. As you know, the notion of the limit of function, which plays an important role in mathematical analysis and the study of calculus. The concept of limit of a function is one of the fundamental ideas that distinguishes calculus from algebra and trigonometry. We use the limits to describe the ways of the function f varies. Some function vary constantly, means small changes in x produces only small changes in fx. X, you can say, that is a input, and fx, the result, that is output, as we have already discussed in the function chapter in detail. So that's the definition of the function, for the unique image concept. As you know, that other function can have values that jumps or vary erratically. Sometimes we face with the problem whose solutions involve the use of limits. According to the formula of geometry, the area of the circle of radius r is pi r square. How is such a formula derived? The usual way is to inscribe regular polygon in a circle, find the areas of these polygons, and then determine the limiting value of this area as the number of the sides of the polygon increases without bound. Thus, even such seemingly simple formula, so that as the area of the circle depends on the concept of the limits of its derivation. We also use limits to define the tangents of the graph of the function. This geometrical application leads to the important concepts of derivative of the function, which quantifies the ways function's values changes. The need for evaluating the limit of the function arises in science and engineering when we come across situations where a function is not defined at x equal to a. However, the value of the function as x takes the value very close to a, symbolize small a. Useful physical notation, for example, instantaneous velocity, acceleration, etc. In the chapter limit, we have to emphasize on the neighborhood of the element. The limit defines as LHL and RHL part. You haven't to bother about the point at x equal to a, what the function attains the value. Function exhibits the behavior in left and right interval. This much only we have to bother in the limit chapter throughout. And the neighborhood concept should be clarified in very crystal clear manner, as this is the base of the calculus. Once you get the understanding of the neighborhood element of vicinity of x equal to a, which is the required point, subject to the condition where we are investigating the function's behavior of the function, so you will get the complete idea of the depth in the calculus. So let's start the chapter limit. In this series, we will start calculi portion, which is first part, that is differential calculus, which is a base of calculus, and its first chapter, that is called limits. So we will go for limits first of all. But before to start limit, we should have a sound knowledge about function. So please go through the lectures and videos of functions also to understand the limits, because we have to take the limits on function only. What is limit? Limit of a function. What's limit of function? Let's consider a function y equal to fx of a continuous variable x. Suppose that the independent variable x approaches a number a. This means that x made as to assume values which becomes arbitrary close to a, but are not equal to a. To describe such situations, we say that x tends to a or x approaches to a, or you can write x tends to a, means x arrow a, we will write later on. So if there is a number L, let's say L, such that as x approaches a, either from right or from left, fx approaches L, then L is called the limit of fx as x approaches a. This is the concept of limit. Although the informal definition of the limit is, so let's say let function fx be defined on open interval about a except possibly at a itself. If fx gets arbitrarily close to L for all x sufficiently close to a, we say that f approaches the limit L or as x approaches a. So, and we write limit x tends to a fx equal to L. Abbreviation LIM is means that is called limit. So that is the limit. Let's just start. In the differential calculus part 1, that is 1.1, some basic concepts of regarding limit. If a variable x takes value which are more and more close to finite number a, then we say that x approaches a, written as x tends to a. If values of x comes closer to a but are always greater than a, it means we are going from right side, then we say that x approaches a from right side, x tends to a plus. But if the second part, that is if the values of x come closer to a but are always less than a, then x approaches a left from a, x tends to a minus. This is the point to be noted over here. So what do you say? For example, if we on the number line, if you consider x equal to 2, so if x tends to 2, what it mean? So let's say if x tends to 2, then x can approach to 2 from two sides, either from left or right. So let's say from right side. If we see from right side, in the notation x tends to 2 plus means x is coming closer to 2 from right. It means you can say on the number line 2 plus means 2.1, and if you come very close to 2, and it mean if you divide the number interval of 2 to 2.1 and you just go close to 2, then you will consider 2.01. Now once again between 2 and 2.01 you divide 10 more equal parts and consider the part which is closer to 2, that is 2.001. This is the way we are approaching from right side, from 2x equal to 2. Now what do you say from left side? Let's say limit x tends to 2 minus, it means closer to 2 from left or less than 2. Limit x that is x tends to 2 minus. So it means between 1 and 2, whatever the number line between near the vicinity of 2, that is 1. So if you divide the entire interval from 1 to 2 in 10 equal parts and consider the part which is nearby 2, that is 1.9. So once again between 1.9 and 2, what the interval is, consider 10 equal parts and pick the closer part which is closer to 2. Pick the part which is closer to 2. So that is 1.99 once again. And if you repeat the same process here, so if you repeat this same process an n number of times, then you find 1.9999 up to how many 9 will be there? After decimal, there will be n number of 9 will be there. This is we are approaching towards 2 from left side. Now, what is the meaning of limit? The meaning of limit is let fx be a function of x. If the expression fx comes close to L as x approaches a, then we say that L is the limit of the function as x approaches a. Now, lim is the abbreviation, that is limit, and limit x tends to a fx equal to L, what we say. And so we say from right limit, what is the difference between right and left limit? Now let's say right limit. If fx approaches L1 as x approaches a from right, then L1 is called the right hand limit of fx. Right hand limit can be expressed as limit x tends to a plus fx equal to L1. Right hand limit can also be expressed as limit h tends to 0 f of a plus h. So you can put x equal to a plus h in the above result, you will get the result of right hand limit. So here h is infinitely small, you say infinitesimally small positive number approaching towards 0, you say. Similarly, that we say left hand limit can be also described like this way. If fx approaches L2 as x approaches a from left and L2 is called the left limit of fx. Left hand limit can be expressed as limit x tends to a minus fx equal to L2, and here once again, as despite of right limit, you can substitute over here, that is x equal to a minus h. So that is limit x tends to limit, and you say limit h tends to 0, then let us say f of a minus h. H is infinitesimally small positive number approaching towards 0. This is left hand limit. Now what is the existence of limit? You know that for LHL equal to RHL, then only limit exists. Otherwise, you can say limit does not exist. Besides, here, for point to be noted, there should be finite value. So the tip you can mark here that a number L is said to be a limiting value only if it is finite and real. Otherwise, we say that limit does not exist, or DNE for brevity you can say. Note that second point, note that A need not be the domain of F. Even if A happens, it means it is occurring in domain of F, then the value of F of A plays no role in determining whether limit x tends to a fx equal to L. It is only the behavior of fx for x near A that concern us, right? So we also note that the three statements over here, that is limit x tends to a fx equal to L. I'll write this also later on. Limit x tends to a fx minus L equal to 0, or you say limit x tends to a fx minus L, well, which is the limiting value, you know, and it's mod. If you take mod over here, then that is equal to 0, are all equivalent. It's okay. I will give the example also later on. Now come to the point for the existence of limits. So finally what we say here, at x equal to a, if LHL and RHL are equal, then only we can say that limit exists. Anyhow, so point to be noted over here, if x increases endlessly or can be made larger than any number, you know, then we say that x approaches infinity. In mathematical notation, we write x tends to infinity. Infinity, you know, infinity is not a fixed number on a number line. Hence, no variable can be equal to infinity. A variable or an expression can approach to infinity. Ordinary law of algebra cannot be applied on infinity. Actually, in other words, you can say that infinity doesn't follow algebraic rules. So infinity minus, example, infinity minus infinity, you can't say 0. Infinity divided by infinity, you can't say 1, as like in other algebraic operation. Anyhow, what infinity follows, which rule infinity follows, we'll discuss later, in detail later on. Anyhow, let's take an example to consider more on limit. If y equal to fx equal to x square minus 4 upon x minus 2, then evaluate limit x tends to 2 fx. So to evaluate x equal to 2, you haven't to bother about fx at x equal to 2, whether it is in the part of the domain or not. If you see here, if we redefine the function fx x square minus 4 upon x minus 2, then you can say that it is, if x is not equal to 2, then it will be defined as x plus 2. As in function chapter, we have already discussed about domain. So you go and discuss the domain and then apply this here, then you will find x equal to 2 is not the part of domain, mean at x equal to 2 function is not defined, due to as 2 is the critical point here over here for this function, as it is in the part of the domain. So the domain at x equal to 2, domain vanishes here, so that in domain denominator vanishes, so we say that domain is not defined over here. X equal to 2 is not the part of the domain, so at x equal to 2 function is not defined even, but yet limit can exist, because we won't concern about at x equal to 2 what the function takes the behavior. So we have to investigate the behavior nearby to. The concept of limit also is nearby to, not at x equal to 2. At x equal to 2, what is the value function obtained over there, whether it is in the part of domain or not, we haven't to bother about that. We have to consider nearby x equal to 2 only. So you say we need to evaluate limit x tends to 2, so x square minus 4 upon x minus 2. So from LHL, if we say it means 2, so what is LHL? So we have to approach towards 2 from left sides. So from left side, so nearby 2, if you as earlier we have discussed that between 1 and 2, if you make a 10 equal parts and pick a part which is nearby 2, that is 1.9. So if you consider 1.9, then fx will become 3.9. So here you can observe this table. So 1.99, here you can say evaluate the value of fx, that is x square minus 4 upon x minus 2, this part. So you will find 3.99 and so on. As we are approaching closer to 2, so the function is closer to 4, you know. So fx is approaches to 4. So 4 will be declared as the limiting value as we are approaching from leftwards. So you see, if we can say that limit x tends to 2 plus fx equal to 4 plus, as RHL, limit x tends to 2 plus here also, here fx equal to 4. Graphical meaning of RHL is this one. So 2 plus, that is 4 plus, it means it is approaching towards 4 also. So what we conclude here, so here we say that in left hand and right hand, the both of them LHL and RHL, both of the value are considering as limiting value, and both are we are obtaining that both of them approaches towards 4. So we can declare as 4 is also distinct finite value. So we can say that limit exists at x equal to 2 and limiting value is 4. So limit x tends to 2, fx x tends to 2, x square minus 4 upon x minus 2 is equal to 4, you can say. To check whether the limit of fx as x approaches approaches a, exist, limit x tends to a, fx exist, we proceed as follows. Number 1, we have to go for LHL. Number 2, we have to go for RHL. And if both LHL and RHL are finite and equal, then only limit x, then only at x equal to a, we can say limit x tends to a, fx exist and equals to the value obtained LHL and RHL, else we say limit does not exist. This point is important over here, you know. So let's we take example over here. Show that the limit of fx equal to 2x minus 1, x is less or equal to 1, and x when x is greater than 1. At x equal to 1 exist, right? So for this what we say here, that limit x tends to means at x equal to 1. If you say here 1, so it means you have to consider the left hand limit and then for right hand limit also. So here what we say, limit x tends to 1 minus, that is left hand limit. At x equal to 1 we have to check the limit. So 1 left side, 1 minus h. So we say limit h tends to 0, f of 1 minus h. And here what we say here, you have to submit this value less than 1. So it is defined according to this function 2x minus 1. So you have to submit this 1 minus h in this x. So that we say 2 times of 1 minus h over here and minus 1. So what we say over here, you just submit this value 2 times of this. So 2 minus 1, that is 1 over here, and that is 1 minus 2h. Now submit the limit h tends to 0. Directly you can submit this value h 0 over here, you will get this value 1. So LHL, that is 1, and similarly you can find RHL also. So what about RHL? In RHL limit x tends to 1 plus. So in 1 plus, that is 1 right side. So this function is to be considered x. So on x, if you submit this value 1 plus h over here, limit h tends to 0, that is of 1 plus h. So simply you submit this 1 plus h, and when you put h equal to 0, that is 1, and this is the limiting value. And hence we say this is the RHL value 1. As you say LHL and RHL, both of them are equal, you know. So this is limit x tends to, limit exist, and hence we say limit x tends to 1. So let's we take another example over here. So here in second illustration, if you say here, evaluate the limit left and right hand limit of the function f defined as fx equal to x square when x is less than 1, x cube when x is lies between 1 to 4, and here mind this point, there is a strict inequality, and x here also greater than 4. Nowhere at x equal to 1 and 4 function is defined. It's okay. Function defined by this at x equal to 1 and 4, and hence check the existence of limit at x equal to 1 and 4. So you see over here, for 1, if we find the left hand limit, so for the left hand limit, that is LHL, and here you say limit, you can say at LHL at x equal to 1, suppose we have to see. So limit h tends to 0, and here we can simply say f of 1 minus h. So as f of 1 minus h, so it is defined by this x square function. So simply you have to say 1 minus h, that is whole square, and here what we say 1 minus h whole square, and then it's you say limit h tends to 0, you can say over here, right? So simply what we recall over here, that is if you solve it, then the result is here 1 minus 2h and plus h square, so all h will be 0, so the result will be 1. And if you see here RHL at x equal to 1, so once again you can have to say that is limit h tends to 0, and here what we say f of 1 plus h. So if you say over 1 plus h over here, then 1 plus h will be go in this function cube, x cube. So simply what we say here 1 plus h to the whole power 3. So if you open this once again, a plus b whole cube, you have to apply this formula. Once again the result is 1. So here limiting value as LHL is 1 and RHL is 1. So limit exist as LHL and RHL both are equal at x equal to 1. So we can say limit x tends to 1 function exists. You see LHL is 1 over here, and RHL also, that is 1. LHL we have already evaluated, and RHL also we evaluated, that is 1. And now we have to see over here, that is at x equal to, that is 4. So left hand and right hand limit at x equal to 4. So at x equal to 4, if you check the function, means left hand 4 means less than 4 you have to say. So you have to go for cubic function, that is x cube, which was defined in the interval, that is less than 4. So we say 4 minus h. Here we have to say 4h minus h whole cube. Here some mistake is there. Let me correct it. So that is function according to this function 4 minus h, f of 4 minus h you can say. Here you can say f of 4 minus h. And yes, and that is 4 minus h whole cube, and here you open it, then 4 cube, that is 64. And when you open this one f of x, here 4 plus h, then is 4 minus of 4 plus h, and opening this bracket, this 4 retaliated and minus h, and that is 0. And here LHL is not equal to RHL, so that we say limit does not exist at x equal to 4. Although limit at x LHL is the value of LHL is 64. Here the value of LHL you can say that is 64. If LHL is asked, then you have to declare 64. It exists undoubtedly. And if RHL is asked, it's also exists undoubtedly, that is 0. But the limit does not exist because LHL is not equal to RHL. So limit does not exist at x equal to 4, you say. Let's take here also, as that is what it was asked, that x equal to 1 minus and 1 plus fx, that is 1. So LHL and RHL at x equal to 1, limit exists and equals to 1. And here limit does not exist. We summarize over here, a limit does not exist at x equal to 4, you see. Let's take another example, that is evaluate the limit LHL and RHL, means left hand limit and right hand limit of the function fx equal to, you say under root of, let me zoom in out, that is x under root of x square minus 6x plus 9 upon x minus 3 when x is not equal to 3, because 3 is not in the part of domain of this function. So when x equal to 3, the result is 0. So here what is asking over here, that is at x equal to 3, and hence you have to comment on the existence of limit x equal to 3. So let's see at x equal to 3 what the limit is. So limiting value when x tends to 3 means 3 minus h either or 3 plus h. The function is defined by this function where x is not equal to 3. So here you have to check the limit, and on solving what we get here, that is the given function can be written as mod of x minus 3 upon x minus 3, because in the numerator that was x minus 3 whole square was there and under root was there, and you all know well, I have already told about this and very many times that under root of x square you can't write x, here you have to write mod x. Okay, so what we say here, that we have to apply mod of x minus 3 because it was under root x minus 3 whole square. So mod of x minus 3 upon x minus 3 and x not equal to 3 and x equal to 3, that is 0. The given function can be redefined like this way. So from this, if you see LHL, that is limit x tends to 3 minus fx, here you say h tends to 0, 3 minus h, and when you solve over here, then you say minus h and minus 3, and that is h upon h, that's related, and the result is minus 1, and RHL at 3 plus, that is the result is plus 1. As you know that LHL is minus 1 and RHL is plus 1, so we can say limit does not exist, right? Anyhow, and now let's take illustration, that is the value of, now we are interested to find the limit of x tends to 1 gi of sine inverse x. Let's say gi of sine inverse x. How to find this? So besides you have to have a knowledge about sine inverse x graph. So let me draw over here sine inverse x graph here. That is the graph of sine inverse x. The domain is -1 to +1, and we have to go for limiting value. This is 1. At 1, the result is obtained, that is pi by 2. For this one sine inverse x, this is y-axis. That's what you call x-axis. This is the graph of y equal to sine inverse x. This is sine inverse x. Okay, fine. So as this is sine inverse x, so we have to go for gi of sine inverse x, and then limit x tends to 1. So directly you can't write over here, that is we substitute simply sine inverse 1 gi of, you get pi by 2. As you know, x equal to 1, what we go for this. So the graph of sine inverse x is like this way. Here what we see, this is the graph of sine inverse x, and the domain of sine inverse x is -1 to +1. The domain of sine inverse x, you say that it lies between -1 to +1. As you know, here it is asking the limit at x equal to 1, limit x equal to 1. So whenever the limit has been asked on any of the function, on any value for any function, so we haven't to bother about x equal to 1. We have to go from left towards and then from right towards. We have to go from right towards and then left towards. So it means we have to approaches from left or right. So now if we go from right over here to check the right hand limit, then you find that this right vicinity of 1 is not participating in the domain of sine inverse x. Then how could you find the right limit? Right limit is not possible. So if in such type of problems, if this situation arises, then you haven't to consider of this right limit. So it means on the boundary values, whenever the point for which the limit has been asked, and it is the boundary points, so you have to consider left limit by default in this situation. So if it is asked x tends to -1, then you have to consider right limit, not left limit. By default you have to consider left limit. So here at x equal to 1, we have to redefine this question. It means question may like this way. If it is asked like this, limit x tends to 1 minus 1 minus sine inverse, it means we are concerning this limiting value at LHL point, LHL of x equal to 1. It means because LHL portion of x equal to 1, left vicinity of x equal to 1 is only in the domain of sine inverse. So RHL, how to find this RHL? RHL will not consider. So in this situation, you haven't to say that RHL we can't evaluate, so the limit does not exist. No, this is not a way. So here by default, you have to find this RHL. Means limit x tends to 1, it is asked, the question is correct. And here by default, the result is The result, what you have to find? You have to find LHL means. It means you have to find LHL, nothing else. So now let's try to find this LHL. How to find this LHL? Let's see. So for LHL, what do you say here? Now let me find LHL. So we say limit, what we say? H tends to 0. Okay. And here we have to submit sine inverse 1 minus H. Sine inverse 1 minus H, that is GI. And sine inverse 1 minus H, it is approaching towards pi by 2. So pi by 2 means pi by 2 bit less than pi by 2. So the GI of this one is pi by 2 here, undoubtedly. Limit H tends to 0, and here the value is 1. So the answer is A option, correct. Okay. Anyhow, let's see the solution over here. Limit X tends to 1, sine inverse X, and here, as we have said, that this is not the part of domain, so we will only find LHL. So we have to omit this RHL portion. We will only go for LHL. Let me mark this point, that we have to go only for LHL, nothing else. This, mark this point. This is the, we have to consider LHL portion only. Okay. We have to consider this LHL portion only. That is a point to be noted. So sine inverse 1 minus H, that is in the graph we say pi by 2 minus H. So we can say the result is here, that is GI of pi by 2, and undoubtedly this is 1. So let's take another example. Limit X tends to 0 plus sine X by X. How to find this 0 plus sine X by X? Let's see. And this denotes GI function. So limit X tends to 0 plus, it means we have to evaluate to investigate the behavior of sin X by X function. Let this, what we have to do, we have to besides we have to compare this sin X by X as, let me clear it about this one. So take me space, let me take some space. So better just draw the graph of sin X and X both in right portion, because we have to consider here right limit. So we have to consider only right limit only. It's okay. Although left limit also same, and if you go here, then you will find left limit will be also same. Later on we will discuss in detail. This is the line y equal to x, and here let me complete this part of sin X also here. This is the dotted, but we are not interested in left portion, means at x equal to 0 leftwards. This is y-axis, let this be x-axis. This is, let's say, pi, and this is the line, let's say this is y equal to x, and here you say y equal to sine X. Okay, so in at x equal to 0 plus means the right side. When you are approaching from right side at x equal to 0, at x equal to 0 over here, then what you will find? Sine X and X, which one is greater? So undoubtedly X is greater than sine X, X is greater than sine X for every value of X belongs to 0 plus. 0 plus means you are considering a vicinity part in interval. So we have to say here, as X is positive on dividing sine X, no inequality will be changed over here, and here what we say, sine X by X is less than 1. So as here sine X by X is less than 1, so this function, entire function sine X by X is less than 1. It means limit X tends to 0 plus, you can say here the value something less than 1. Limit X tends to 0 plus, which is asked over here, and as this is GI sine X by X, so the result will be here somehow less than 0. Sorry, less than 1. So less than 1 means 0 point something. So whatever the GI is, the result will be 0. So B option is correct. Okay, fine. So let's take another example. Before this, we have to take the solution over here. So you say limit X tends to 0 plus sine X by X GI RHL at x equal to 0. That is 0 plus H and 0 sine H by H. You have to find this as y equal to X is above sine X, the graph here. So we can see over here that is sine X, right? So sine H by H, you say that is less than 1. So 1 minus, that is the result is 0 here. So RHL value is 0. Now take the example 3, illustration 3, you say fx equal to x minus mod of x, and when x is not equal to 0 and when x equal to 0, that is 2,
and here there are 4 options: 2, 0, 1 and does not exist. You can also try yourself, pause the video and try, and then if you won't get the solution, then you come and see the solution. So did you figure it out of illustration 3? Let's see. So here what you have to do, at 0, left limit and right limit both you have to solve. So better just solve the left hand limit. Here left hand limit for LHL, for that what is say limit x tends to 0 minus, it means you can say limit h tends to 0 over here, and here we say f of 0 minus. F of 0 minus, it means function where x is not equal to 0 is there, you have to consider this. It means this is minus h minus mod of minus h, and here that is what we say, that is minus h. For this, that is h is not equal to 0, that what we say. Now solve it, as this is minus h and this is a variable here, so this is minus h, and due to this mod this will become plus h, but before this minus h sign was there, and here that is minus h. You can say here this is minus 2h and h minus h. Here once again limit h tends to 0, you can say. Here also limit h tends to 0, you can say over here. So finally that is minus 2h upon h, and this h related, and the result is minus 2 upon minus 1, that is plus 2. So LHL, you know, that is plus 2, and if you find RHL over here, then what we will get, so limit h tends to 0, you know, f of 0 plus h, you say f of 0 plus h over here, and when you put over h minus h mod, that it means of course it is positive h, so that is h, and here that is 0. So RHL is 0 and LHL is 0. As you know, LHL is not equal to RHL, so limit you have to say does not exist. And that is the important point here to be noted. If LHL is not equal to RHL, then limit does not exist. Let's say take solution over here. So at x equal to 0, in the left side the limit is 2, and here you see the right side, the RHL at x equal to 0, that is limit does not exist. So okay, this lecture will be continued further, and we'll take more on illustrations and more topics we will watch over here. And before this, hope so you all are enjoying the limit session, and to just make a more stuff in limit, you have to go chapter function, revise it properly, because the limit on where you have to operate only on a function. So and later on we'll discuss indeterminate forms and how to attain the limiting